Looking at my second page of notes, we want to take a look at something called net change. As my input x's change from some a to some b, how do my outputs, my y's, or my f of x's change? F of b minus f of a. What is the net gain or loss of my y coordinates? So if I take a look at f of x is equal to x to the third minus x, we want to find the net change from an x of 3 to an x of 5. So let's find out what y coordinates go with those. When I plug a 3 in for my x, we're going to have 3 squared minus 3, and 27 minus 3 is 24. Then when I plug a 5 in, I'm going to have 5 cubed minus 5. 125 minus 5 is 120. So if I start at 24 and I'm going up to 120, that's going to be a net gain of 96. I'm going to take my f of b, 120, minus my f of a, 24, and that's going to give me a net gain of positive 96. So I'm going up 96 units from an x of 3 to an x of 5. The next thing we want to do is review our domain, our limitations on x, and when we write our domain, we want to be able to write it in our set notation. So if I factor my denominator here, I can see that x cannot be equal to 2 or negative 2. So if I start at negative infinity, I can go all the way up to negative 2. I'm going to skip over negative 2. I want all the numbers between negative 2 and 2. I'm going to skip over 2, and I want all the numbers from 2 out to infinity. For number 6, if I have a square root, I know that whatever is underneath my square root has to be greater than or equal to 0. So let's take our 2x minus 5 and make an inequality. It has to be greater than or equal to 0. So that's going to give me a 2x is greater than or equal to 5. X has to be greater than or equal to 5 halves. For some of my domain here, I'm going to start at a positive 5 halves and include that and go out to infinity. We like, for question number 7, all odd radicals. Odd radicals are awesome because I can have a negative or a positive underneath an odd radical. So if I have an odd radical, my domain is all real numbers, from negative infinity out to positive infinity. Number 8 is a combo problem. Notice that we have a square root in the numerator, and then we want to factor our denominator. So I've got to take care of that square root in the numerator. X has to be greater than or equal to 0 from the numerator, because I have a square root. Now, when I factor my denominator, I'm going to have factors of 2x minus 1 and x plus 1. I know that my denominator cannot be equal to 0, so x cannot be equal to 1/2, and x cannot be equal to negative 1. Well, if x already has to be greater than or equal to 0, then I don't even have to worry about the negative 1 because I'm going to start here at 0, go up to 1/2, I'm going to skip over 1/2, and I'm going to go out to infinity. So we just wanted to review finding the domain, but writing our answer in set notation. The last thing we want to be able to do is evaluate. And for these ones, you just want to be real careful plugging things into your calculator. Make sure that you always use parentheses around your denominator. Okay? Make sure that you're only raising the x's to the certain powers and that you're taking the square root of the entire object. So number 9 says, when the brightness x of a light source is increased, the eye reacts by decreasing the radius r of the pupil. The dependence of r on x is given by the function r of x is equal to this lovely square root of 13 plus 7x to the 0.4. all over 1 plus 4 raised to the, 1 plus 4x raised to the 0.4. So when the brightness is increased, the radius of my pupil is decreased. So let's take a look at when my brightness has a level of 1. So if I want to find r of 1, then I'm going to have the square root of 13 plus 7 times 1 to the 0.4 is just 1, all over 1 plus 4 times 1 to the 0.4 is just 1. So that's going to give me 13 plus 7 is a 20 over 5 is 4, and the square root of 4 is 2. Then if I plug a 10 in, I'm going to have the square root of 13 plus 7 times 10 raised to the 0.4 all over, be real careful, make sure that denominator in parentheses, 1 plus 4 times 10 raised to the 0.4. You should get, when you plug this into your calculator, 1.6638, so forth and so on. So let's go ahead and simplify that to 1.66 millimeters. And then our last one. And you just want to be real careful. Make sure you can plug these guys into your calculator. Now 13 plus 7 times 100 raised to the 0.4 all over 1 plus 4 times 100 raised to the 0.4. This should come out to about 1.476 and change, so 1.48. B says, find the net change in the radius as x changes from 10 to 100. So it's going to go from 1.48 minus the 1.66, which would be a negative 0.18. So those are our new problems for today. Okay. Make sure you can plug things accurately into your calculator.